Good morning. It's Mr. Crouch. So, Physics 12 momentum. So, two-dimensional momentum in a 15-minute YouTube. You might be able to get her done. So, this is from the big physics textbook, the one that looks like this. That big physics one. Principles and Problems by Glencoe Science. And this one is from page 243, number 22. And the question says, a 925 kilogram car moving north at 20.1 meters per second collides with a second car, a 1,865 kilogram car, moving west at 13.4 meters per second. So they hit and stick together. One's coming this way, one's coming this way at 90 degrees, and they hit and move off together. So they stick together, and what is the velocity of the tangled wreckage, both cars together, after the collision? That's the question. And when they say what's the velocity, they mean what is the amount in meters per second, and what is the direction too. We've got a situation like this. M1 is moving to the north, M2 is moving to the west, and they collide like that and then move off in that direction together. Just adding a little bit more information. So the V1 initial, the speed of the M1 initial, is 20.1 meters per second, and the initial speed of the second mass is 13.4 meters per second to the west. So in terms of momentum, we have one momentum going to the north. It's M1 times V1 initial. And we have a second momentum, which is M2 times V2 initial, and it's to the west. So you know that the combined momentum is something like M1 V1 that way, plus M2 V2 that way, so it'll be something like that. So it's no surprise that the initial momentum of the two of them, north and west, making the hypotenuse, because they are at 90 degrees, will equal the final momentum, because that's the law of conservation of momentum, that the initial total momentum equals the final total momentum. So, to continue, more information here. The initial total momentum of both those two masses have to equal the final total momentum of those two masses. And let's make these momentums then, not just M1 times V1, but let's just make it a momentum, which is mass times velocity. So we'll go 925 times 20.1, and that will be the momentum to the north in kilogram meters per second. And then we'll go M2 times V2 initial, which will be the initial momentum of M2, and it'll be to the west. Now then is the initial momentum to the north is 18,593 kilogram meters per second, and the initial momentum to the west is 24,991 kilogram meters per second. The law of conservation of momentum says the initial total momentum has to equal the final total momentum, so that vector in that direction plus this vector in that direction have to equal the final total momentum. So let's get that initial total momentum. It's that vector plus that vector. So 18,593, and then at 90 degrees, 24,991, we'll have to get that hypotenuse. Showing the two initial momenta, we've got 18,593 kilogram meters per second to the north, and right where that one ends, add the second vector, which is the second momentum of the second object, and it's 24,991 kilogram meters per second. So if you look at this in terms of vectors, we've got one vector adding to another one. The resultant vector, the result of adding the two vectors, is that hypotenuse, and it's this angle. That hypotenuse is the initial total momentum. That has to equal the final total momentum in any collision or explosion. So this hypotenuse at that angle has to equal that final momentum at that angle. So all I need to do now is just find out what this hypotenuse is. That will be the combined total momentum after the collision, because it was the combined total momentum before the collision. And I also have to find this angle, because that will be the angle that the wreckage moves off in after the collision. To get the hypotenuse, we just use Pythagoras' theorem. There is a 90-degree angle in here because it was north and west. And that's important. If it wasn't, you'd have to use sine law and cosine law to solve this particular problem. But because there is a 90-degree angle, we just go h squared equals adjacent squared plus the opposite squared, or h squared equals a squared plus b squared, whatever you want. And we just have to go through and do this algebra now. And using the calculator to find h, we just go that one squared plus that one squared equals, and then root it, because you don't want h squared. You just want h, and we get 31,149 kilogram meters per second. So that's the initial total momentum. That has to be the final total momentum as well. The final momentum for both objects is 31,149, as it was for the initial total momentum. Now this 31,149 is both cars stuck together moving in that direction. So we will need to find this angle right here that they're moving off at. That's theta. So it's not north, but it'll be west of north. And we also need to find out what the velocity is. So this velocity comes from P is equal to mv. That's the final combined momentum. So both of them stuck together. That mass has to be both of them stuck together. And that will be the velocity of both of them. So that 31,149 will go right here. This will be the mass of both of them. And then that will end up being the velocity of both of them. And we'll show that right there. The math, just the momentum of both of them together is equal to the mass of both of them together times the velocity of both. It'll be the same velocity for each one. They're stuck together. So whatever velocity you have of one, it is the velocity of the other. And putting the numbers into the equation, we have the combined momentum of both of them after the collision, 31,149, is equal to their combined mass, m1 plus m2, times whatever speed they're going after the collision. I haven't put the units in here, but as long as we're kilograms, meters, and seconds, your velocity will turn out to be meters per second. So we've got kilogram meters per second, kilograms, that will be meters per second. And the final step coming up, speed for both of them stuck together of 11.2 meters per second. Rounded up to 3 significant digits. Let's find out what this angle is too, because velocity isn't just speed, it's the direction that it's moving into. So we know that it's not going north, it's west of north. But how much west of north? We'll find that theta right now. Let's find that theta. Numbers, we get tan theta is adjacent over opposite, like TOA, T-O-A, should be, not A-O. Opposite over adjacent, which I did here, but not here. $24,991 over 18,593. You can see it'll be more than 45 degrees anyway, so this better give us an angle greater than 45 degrees. Make sure your calculator is in degrees, not rad, not grad for sure. You're in grade 12, you haven't even graduated yet. You get 53.3 degrees west of north. So not north, but west of it. And that's your answer.